Welcome. We're talking today about 10.3. This is infinite limits and limits at infinity. Okay, so before we get into any problems, I wanted to just look at a couple sort of examples that are indicative of everything we're going to be doing today. Okay, so let's take a look at, first, let's take a look at y equals 1 over x. I sort of started to look at this in the last video, but I really want to look at it a little bit more today. If we look at y equals 1 over x, this looks like so and so. Okay, so now a couple of things I want to sort of point out the different limits that are going on here. Let me make this, put this in the center of the page. Make that a little nicer. Okay, first off, up here, what we have is we have the limit as x approaches 0 from the right of 1 over x equals infinity. Okay, now one of the things that I think is sort of nice to do is we can also think about this as like we can plug in 0 there. Okay, so we can take the limit as x approaches 0 from the right of 1 over x is 1, and then I'll put like 0 from the right. Okay, and what that means, or how I interpret that, is that this is a very small positive number. So 1 divided by a very small positive number is going to be infinity. Okay, in contrast, let's look down here what's going on. Oop. Down here what's going on. Okay, well, the limit as x approaches 0 from the left of 1 over x equals negative infinity. It's going to negative infinity. And we can think about that in terms of one over 0 with a small negative, and let me zoom in on there. That small negative indicates that we're taking it 1 and dividing it by a small negative number. Okay, so 1 divided by a small negative number is going to be now negative infinity. Okay, so now we have no way of speaking about the limit as x goes to 0. So the limit, let me write it here, the limit as x goes to 0 of 1 over x, there's no way to define it. So we're going to say does not exist. Okay, now, even though those left and right-handed limits also don't exist because they're infinite, so infinity is not really a limit, we still write it, okay? So there is a little bit of a subtle point there. I want to sort of make sure we understand that it's there. Don't need to understand why it's there, but it's there. There's a subtlety there I want you to think about, okay? Now let's talk about what's happening here. Here, we're taking the limit as x goes to infinity of 1 over x. Now this one, we're taking 1 divided by infinity. That's going to be 0. Okay, and then the same thing's going to happen over here on the left. As x goes to negative infinity, the limit of 1 over x is also going to equal 0. Okay, so far so good? Okay, and then we could do a similar thing with 1 over x squared. I won't get into as detailed a discussion. Okay, other than to say, what's happening here? Let's move this one up out of the way. Okay, so what's happening here? Let me put a little barrier between them. Okay, so here, the limit as x approaches 0 from the right of 1 over x squared equals infinity. Okay, and if you put this, if you put a 0 in, right, that's still going to be infinity. Okay, but the nice thing is that it happens from the left too. Okay, because we can put in that 0 minus, but you're squaring it. So when you square a small negative number, it becomes a smaller positive number. Okay. So that becomes infinity again. Okay. And then on the ends, the same thing happens. Limit as x goes to negative infinity, 1 over x squared is 0. Limit as x goes to infinity, 1 over x squared is 0. Okay? All right. So those two examples in mind, I want you to keep those examples in mind whenever we get lost, okay? All right. We'll see you in the next page.